All right, we're back. Uh, so part two, I have to add like a freaking billion or something. Actually, what number is this? I don't know. It's like 10 trillion or something. A big old number to the position of each prize. And well, I tried that with like the same strategy I was using earlier, and we get a stack overflow. So that's not gonna work. So I'm gonna have to come up with something a little smarter. The way I'm doing it right now is like I'm checking all the combinations, but that's obviously way too big. And I was thinking, I wonder if I could use something like A star or like Dijkstra's. Yeah, would I be able to do that? Um, would I be able to do that? I think Dijkstra's is like simpler. I don't know. Let's look up A star. Yeah, actually, let's do Dijkstra's. I think it's easier to implement. I've done both before, and I think Dijkstra's was simpler. Dijkstra pathfinding. We'll go to Wikipedia. Wikipedia. I don't know if this is gonna work or not. There's some pseudocode here. So, oh yeah, we need to make like a graph. And like I said, the search space is freaking ginormous. So I'd have to make a graph. I'd have to make a graph for each one of these machines. And like, how big is too big? Like, just to test, can I do... Yeah, what will my graph be? Well, my graph, I'm gonna use probably a map. I think that's how, like, they kind of treating it here too. Yeah, just assume let's grab it. Wait. Oh. So this is with a queue. Why priority queue? Oh, yeah, well, it's not really the... We're not really looking for, like, the shortest path, are we? We're looking for, like, fewest number of tokens. So... Well, our distance is going to be... Get out of here. Oh my gosh. Oh, it does not... Okay. Yeah, and like the distance will be... Or like we'll have the cost... can I use Dijkstra's for this? Distance to V. So should I do number of tokens? And if I make the graph, yeah, so the distance is going to map a vertex to the cost. Yeah. The number of tokens. Prev. Yeah. This will be the actual nodes of the graph. Boop, boop, boop. Well, to make that graph, I think you just want to do like a DFS. Do a DFS to make the graph. Like, how far should you search though? I think long dot max value. And that would give me a graph. Dang, this one's kind of hard. I don't know exactly what I should do. Will this even... Let's see. I want to see, like, are we making it through any of these? Oh, we're already printing that out, so we'll be able to see that. So yeah, we are actually. Oh wait, we're probably no, we're not. We're not making it through that one. I think I could use Dijkstra's for this. I mean, how else would you do it? I mean, let's just start trying to jam something out here. So I need to make the graph first. Let's see if I can even do that. So to make the graph, I'm gonna do like a DFS, and the graph. So for the graph, I'm gonna have a graph and I'm gonna have a distance map. And what am I mapping? mapping. A vertex. And what is a vertex? It's just a pair. It's going to be a pair. Yeah. So the graph is going to map a pair to a pair. Oh yeah, it should be a long to a pair. And the distance map, I'll call it cost, is going to map a distance. Wait, what the heck? This is going to be from a starting position, right? Or something? Yeah, for each vertex, distance to vertex equals infinity. Okay, so this is actually inside of a loop. Let's try to do it just like this down here. How do you even spell Dijkstra? Oh. Oh, you need to make the graph first. So you gotta make the graph first. Oh my gosh, how is this gonna work? This is about to be crazy. It's gonna map a pair to a list of pairs. Oh boy, I don't know if this is gonna work. It's gonna be too big. To a list of pair. So to make the graph, let's see if we can even make the graph first. Build graph. To build the graph, we're just gonna do like a DFS. So you're gonna start at and you're gonna be given your steps. Oh crap. Oh my goodness. I don't know if this is going to work or not. You're going to have the crane position. You're going to have the... You're going to have the... You have the crane position. The steps. And I don't know about this. I'm gonna build this graph. I'm gonna build a graph. How the heck how do you build a graph? Like, what is a... Oh, frick. It's basically going to be the combinatorial thingy. It's basically going to be this. But we get Stack Overflow. Yeah. That's for num presses. What? Hold on. What if I did, let Let me see something real quick. What if I added if this guy? I don't think that matters. It's not gonna. Yeah. Let's see if. Oh my gosh. Yeah, do it like this. Let me see this thing. Crap. Dang, how do I do this? Let me see like how much time people took to solve this. Let's see like how much I'm overthinking this. Yeah. So Jonathan Paulson, he took like 35 minutes. I gotta finish this one, man. Day 14's coming out. Let's see what Jonathan Paulson did. I'm just gonna get some hints.
Okay, as of until day 13, it's started right now. What we got? We have some kind of but. So what are we supposed to do here? Well, like find this cheapest way to make some kind of cycle.
Oh, do you think I'm getting stuck in a cycle? Oh, if it overflows, you don't really know, huh? Yeah, if... This isn't gonna work. You can't say if it's it's never gonna be greater than. It's not even possible. Yeah, because like... Real quick. It's just gonna overflow, doesn't it? Yeah, I'm dumb. Yeah, so I'm getting stuck in a cycle. That's all I need from you, Jonathan Paulson. Yeah. That's what it is. I'm such a goofball, man. Yeah, you can't, that's all it is, I think. This. It's always going to be less. It's going to roll over. less than 0? We'll say if it's greater than 0. Yeah, what if I just do that? It's greater than 0. What if I just say that, huh? Look, what if I say if it's just greater or equal to 0? What if I just say that? What if I just do that? Huh? No, still get a Stack Overflow. Why? I got a Stack Overflow. So I guess a stack is Betty Big. Let's do like a little test file real quick. I just want to see something. I just want to see something here. Oh, I already have one. Yeah, open that up. Yeah, I was just playing with something here. Come on. Wait, why am I in code right here? Oh. Just want to see something here. There's no Gradle project in here. Come on, wake up. You're being super slow. Please hurry up. Come on. I mean, I don't need autocomplete, but gosh. So slow. Are you still searching? What are you searching for? Come on, man. We're gonna return. Else, we're gonna recur with x plus 1. I'm just gonna call recur. Is that gonna work? Just see if it works real quick. What do you mean? What the heck? Where am I right now? We're in test. What the heck are you talking about? Brother, what? Okay. What if it's like integer Dude, what the heck is wrong with this dang thing, man? Even that's too much. I just want to... Is it... I'm not screwing it up, right? Yeah. So, that's just too many... It's too big. It's just too big. It's just too big. It is just way too large. So that's not gonna work. It's not gonna fly. I mean, it is... Let's see. You can only go up and to the right, but you have two options for that. What if I did this with a stack instead? You want to try it? Yeah. So you'd have directions. But you can only go up and to the right, like I said. What the heck, man? Dang, this one's hard. Alright, I'm actually gonna keep watching Jonathan Paulson.
Reduce two dimensions. These numbers got not that big, right?
Oh, is he just kind of like manually searching for it?
This is not the right answer.
Um.
Still not the right answer. Seven, five, nine, six, two, six, six. So what's my point here? We want to go in a diagonal direction for a long time, and then we want to like deviate at the end to actually get the optimal choice. So I'm trying to handle those two stages differently. Currently I'm thinking maybe a diagonal direction too long. Not sure about.
Just move.
This is pretty slow. We'll solve this a lot. Okay. This is like very slow. Think bigger. I'm a little hesitant to keep saying answers because I think with my phone it's just like getting worse. Something actually makes it different. What do you think these numbers? Well,
No way, that's what you gotta do. There's no way, dude. Huh? Solve linear matrix equation. Matrix. Well, let's think about this for a second. Hmm.
Okay, that was, I guess, which that would be. Yep, that's the place.
How did you do that?
Okay, well, let's write that up. I will attempt to explain what I did, even though I think clearly what I did was pretty bad.
How'd you do that?
Okay, so let's make this solve with by 1.2. Pulse 2. I think that will eventually bring out the right answer, so probably 1.2, but as we can see, I'll try to explain this code. much, when you press EDX, it's this much, Y goes up by this much, and you have a target. And it costs $3 to press A, and it costs $1 to press B. And the question is, how much money does it cost to enter the target? If you play optimally, or 0 if you can't do it, and just sum that up over all of the inputs here, which there are apparently 320 of. So in point 1, this is relatively easy because the numbers are small. I just did a dynamic programming solution.
Yeah.
So
That's
we're
what I
saying,
did too.
what's the cost of getting? Minimum cost of getting X and Y. So if we're at the target at 0, if we've gone negative, we've gone too far, it's impossible, so we turn infinity, and otherwise try pressing button A, in which case you turn X minus A, X, Y minus A, Y, at a cost of 3, or try pressing button B, in which case you target X minus BX, Y minus BY, at a cost of 1. So
Wait, why is it returning 0
try
out
those
there?
possibilities, memorize it so it's fast, and then just solve. This is going to turn the answer for one, or whatever. And then just solve, solve when that key on the original target. And if you get a finite answer, then get that initial score. So that's part 1. Numbers are small. Part 2 says, okay, now add 10 and 14 to the targets.
10, 14.
So now our DP would have 10 and 28 states, which is way too much. So we need to do something fast. I figured that what we should do is we should figure out, this number is huge compared to the initial prize numbers. So we need to go almost at a perfect 45-degree angle. And then we need to do something, finicky at the end maybe. So I figured, okay, what is the cheapest way to go at a 45-degree angle? So try all possible combinations of 600 presses each button. This is kind of stupid and excessive, whatever. Figure out the cost if doing all those button presses, and how much that moves you in X and Y. And if it moves you at a 45-degree angle, then we can calculate the cost per degree of movement. And we're going to find the cheapest way to go at a 45-degree angle. That's the idea. So from this calculation, we say, okay, the cheapest way to move at a 45-degree angle moves this amount and it costs this much. And then we're going to say, okay, well, we're going to do these button presses for a long time. So I figured until within 40,000 units of the goal. This parameter I had to keep increasing because I made it too high. So let's start by assuming that we did that, and then we got to amount times dx, x amount times dx, y, and then we just ran a dp for the bit at the end. And assuming that dp was solvable, we can return our answer from this smaller state plus the amount that it costs us to get to that super far diagonal direction. So that's all correct. Some problems with it is that it's very slow because you need to run this dp on this kind of big thing at the end, and also this brute force stuff at the beginning, although that's relatively cheap. And also, it's not clear what these parameters should be. So initially I set them too low and I got wrong answers. I think mostly because I was marking some states unsolvable because I was going too far in the diagonal direction, and that didn't leave you with enough wiggle room to get to the destination. Yeah, so that's what I did, and it did eventually work, but it was very slow, and I submitted a bunch of wrong answers. So presumably this was not the right thing to do, and I will be interested to see what that was. But until then, see you tomorrow.
Dang it. Dang it! So he basically did it like a ghetto, super ghetto way. Huh. Yeah, because we are inside of a big grid, right? The search space, just imagine it like a big old matrix. And the crane starts at the very bottom left corner, and the prize is at the top right of the grid. So yeah, you basically, yeah, you just want to go straight for some amount of distance, but not too far. And then you kind of do like originally what we did. Huh. So choo 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 choo. Oh boy. So So, yeah, let's see. Move straight. I just want to finish this, dude. The new one's coming out in a couple hours. We're going to move straight. We're going to take in a couple of longs. It's going to be CY. I want to do Y first. CX. CY. And I am going to need the steps too. I'm going to need the steps too, so it's going to be, those are ants. X A. I was calling it AX. AX. AY. BX. BY. Oh, you should actually make those longs too. And we want to just move them. We just want to move them straight as we can. So how the heck do we do that? So yeah, how the heck do we do that? So let's see here. How the heck did he do that part? T1 is in range 600, T2 range 600. The cost three times. Okay, that's the number of tokens. Times T1 plus T2. And then, wait, what? And then dx is ax times T1 plus bx times T2, and then get the y delta and if the deltas are the same, if the deltas are the same, that's putting you on the straight up on the diagonal. And dx is greater than 0, then we say the score is delta x divided by the cost. Wait, why is the cost? Whatever. Delta score is 5. If best is none, or scores less than best 0, huh? Okay, and then he says best equals the score, the T1, the cost, the dx. If best is done, returns 0. And so he does, just decomposes the best real quick. The amount is, what the heck is that? What the? I really don't know what he's. The amount is P2 minus some number. Yeah, I think you could do this with like what do they call it? Diphantonine equation or something like that. Yeah. P2. And then just doing the same old combination thing. And enter. Wait, what? Oh, okay. PX plus. Okay. Okay. Yeah. So he's just starting. Yeah. So yeah, you just need to start it like further. You basically just want to start your search further into the matrix instead of trying to do all the way at the beginning. So he basically by just guessing some constants was able to basically start the search further up in the matrix. Yeah, so I'm gonna kind of copy him. You know, hey, my only rules is no generative AI this year, okay? That's all I'm doing. I can still copy humans. And I want to do day 14 tonight, so let's see. So, to find... Yeah, we just want to move further up into the matrix. So, yeah, move straight. I'm gonna kind of copy. I'm literally gonna copy him for now. So, what is T1 and T2? What, those are just like. Why does he call him T? I'm just gonna say I and J. I is less than. I'm just gonna use the numbers that he did for now. And I'll see if there's a way to parameterize this and do it smarter. And after I do this, after I get it solved, I'm gonna look at some other people's solutions, see if there's something smarter. I'm sure there is. Like, can you use Dijkstra's? I feel like you might be able to. And he says that the cost is yeah, the cost is like 3 tokens plus that J. Yeah, I guess I could call this A and B. No, not that one. Call it A and B. And yeah, the delta X is going to be AX times A, yeah, plus AY no. BX times B and then the other guy, delta Y equals AY times A plus BY times B, and then if the deltas are equal, we're on the diagonal. That's what we want. If delta X equals delta Y, he says or, oh, and delta X is greater than 0 is what we want. Because if we're, I mean, you honestly don't even need that. You could, I'll fix it in a second. Then you make a score equals the dx divided by the cost. It's going to be the dx divided by the cost. And then if best is null or score is less than best 0, then best equals, we're saying score AB cost delta X. So we're only considering when they're equal to each other. If best is null, actually I should just return best. And what the heck is that? Equals best. Wait, is he ever even using it again? Yeah. Yeah, he is. Yeah. Return best. And it could be null. So, yeah, for every one of those... Yeah, we're going to keep doing that. And we're going to get... Move straight. And we want to get... we want to get the steps, which are the last four. So 0, 1, 2, 3, 4, 5. Okay. And then I'm going to pass that with this. I'm going to pass that with that. Goodness gracious. And then in here, we're going to have an amount. Should keep adding args. Oh my gosh. What is that, like 13 arguments now? It's going to be this number. Minus just some numbers, what he did. And then for getting your number tokens, it's all going to be the same. Oh yeah, if X and Y. Yeah, we're gonna say right. Less than 0. Why would they be less than 0? Damn it.
Too low when I got wrong answers.
X minus AX. Oh, he's just doing, is he doing it backwards? What? X minus AX. What the heck? Hold on. PX. Huh? Mm-hmm. Oh, wait, what? What is PX again? Huh?
mostly because I was going through some states unsolvable because I was going too far in the diagonal direction and then leaving with enough like wiggle room to get to the destination. Um,
Man. I'm literally just copying somebody right now. Jonathan Paulson. So if it's that, I'm just gonna copy him. If CX what is that condition even for? If x is less than 0, I think that means you overflowed, right? CX. Okay. Answer. And then we say result equals math.min the min of these, basically. And this is moving the A. This is moving that guy. And he says x cx minus ax, which is interesting. Y minus AY. So now you don't use num presses. And then same thing here. Interesting. And then you map the result. And then you return that result. And then up here, yeah, it's basically the same. Huh? Doing something wrong. Oh, what? Oh, yeah. It's going to be PX, which is this. Dang it! Hey, where's my remote? What do I do with that thing? What the heck? Actually, where did the remote go? Where's my remote? What the? What in tarnation? Oh. Yeah, I need to fix my method call now. Oh, yeah, okay. So you actually don't need it in here. You do need it up here. And it's going to be the position X plus position X plus that P2 minus the amount times the delta X, which is 0, 1, 2, 3, 4, fourth index of best. And this is PY plus P2 minus that amount times the same thing, delta X, which is best 4. Ew. That's still not giving me an answer. What? Let's clean this up. I don't need that. Don't need that. Don't need that. Oh. Hey, what? Oh, yeah. Let's see, that's PX. Oh. Yeah, I still need a lot of those in there. Just don't need these anymore. Oh, what the heck? 2, 3, 4, 5. Right, I think... What? What am I... God dang it.
Yes, that's what I did.
One, 2, 3. What am I missing here? So that's PSP line. Oh yeah. Oh yeah, that will be 0. Huh? Wait. Oh. Yeah, you actually don't need that anymore. Because we're just like counting down. So, yeah. Help. Help me. Mm-hmm. 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 Wait. Wait. Oh, that's my problem. No. Wait. What the? What? PX.
That's PG was solvable. So if I
Hmm. Oh. So just get rid of that then.
One is relatively easy because the numbers are small. I just did a dynamic programming solution. So we're saying, what is the cost of getting? We know cost of getting X and Y. So if we have to target at 0, if we find negatives, we've gone too far, it's impossible, so to infinity. And otherwise, try pressing button A, in which case you can show there's X minus AX, Y minus AY, at cost of 3, or try pressing button B, in which case you can show there's X minus BX, Y minus BY, at cost of 1. So try those two possibilities, memorize it so it's fast, and then just solve this. I'm going to return the answer for everyone, or whatever. And then just solve, solve when that's the key on the original target. And if you get a finite answer, then give that a true score. So that's part 1, which is small. Part 2 says, okay, now add 10 and 14 to the targets. So now our DP would have 10 and 28 state.
Okay, that looks good. If best is null. And then when you call it's gonna be px plus p2 minus that amount times the dx, which is that 0, 1, 2, 3, 4. And then the other one. Mm-hmm. 2, 3, 4, 5. Interesting. What the heck? Wait. 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 Huh. I don't know. What if I make it a double? No, those are exactly the same. So, that's not my problem then. I think I'm doing it exactly like Jonathan, man. Let me just double check this. Oh, he's not even on the leaderboard. Oh yeah, he is. Why just so hard, man? I'm cheating, I know, I'm sorry, I'm cheating. I just want to be done. Huh, is he even using this? No. Oh, I guess he just has that in all of his things. So, what if I just try writing it exactly like Jonathan Paulson? What the heck is this? Oh, okay. Oh, what? Oh, okay. What's the problem here? What's the freaking problem? Oh, I thought that was a comment. I'm so dumb, dude. Divided by dx. That's integer division in Python. Oh my gosh, man. Oh, mine's super slow. Was his slow like this? I think it was. Oh gosh. Oh goodness. Wait, what is that? Oh boy. They're 4 lines apiece. There's like 300 of them. Oh boy. Dang, mine is... What happened? Oh gosh. And my search space might be different. So... How did other people do this? I'm gonna find out shortly. There's gotta be some... Yeah. Seems like you would be able to use like Dijkstra's or something. At the same time though, it's like... This won't take... It's not taking too long. I mean, it's taking a long time. I want to see if I can do it with Dijkstra's. I just want to get the answer in. Come on, please. I hope this works, dude. This one's actually difficult. Like, I don't think it'll ever be the case. So if you just imagine that the crane starts at the bottom left corner of a matrix and the prize is at the top right corner of a matrix, I don't think there should ever be a case where you would need to like leave the bounds of that rectangle to get like the shortest path. So I think if you could just make a grid of nodes and then use Dijkstra's somehow. It's not really like that though, because it's got like the combinations in there too. That seems really small. That seems like way small, dude. Oh, that's not right. That seems way small, bro. Yeah, what the heck? What am I doing? Help me, Jonathan. So I get the best thing with 2, 3, 4, 5. Yeah. And doing that. Yup. Okay. Oh, whoa, 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 whoa. Yeah, we're definitely not doing that part. Oh, crap. Yeah, you do need to pass amount and cost. I'll just pass best. I'll just pass best in there. That's what I'm not doing. What the heck? Ten to the 15. 10 to the 15. What? $14. Oh, so that's 10 to the 14. Well, what is he doing right here? Where he's like... I'm gonna call this tokens. Tokens. And if tokens plus amount times best what? 0, 1, 2, 3. Like that? Well, he's saying 10 to the 15. Let's just do it like that. Ten to the 15. Oh, how do we get out of this? Oh, goodness. Oh. What an interesting solution. That guy's a genius, man. His brute force is just like, he just found a way. I gotta look at some other people. I bet somebody has a good solution for it by now. Probably won't get to it tonight, though. Gotta do day 14 when it comes out. Huh? Yeah. Dang, dude. Do I count this? Yes, I count it. I still count this. I think I got a little help on some other ones too. There's like 300 of them. And what is cost again? Did I overflow? Oh my gosh. Alright, let's wait again. What happened? Oh. That's a lot of tokens, man. How are you gonna carry all those tokens around? It's running a little bit faster now. I think it was all that like. No, it's about the same. Day 13 kind of whooped my butt, dude. Also, I started on it pretty late. Went out with some teammates last night. When did I start this? Dude, I think I started this like 5 hours ago or something. Like part 1 anyway. I don't know. Dang, dude. I'm gonna be depressed if this doesn't work. That's a big number. Please. Please. It's not like your time get longer every time. No! My answer is too high. Why would my answer be too high? probably because whatever these constants are particular to our different inputs. If it's too high, then I probably went too far. Dang, man. My answer's too high. We'll take a little break here and just see what others are doing.